Right, we'll start. This is week 3, lecture 5, and today I'm going to, and in fact tomorrow, I'm going to revisit the object-oriented concepts, but this time we're going to look at it using C sharps. Now you've done OO programming right from day one in Java when you began first year. Okay, now you probably didn't do OO actually day one, but you were exposed to Java on day one, and that was an object-oriented language. Okay, and then you discovered object a little bit late in the day after you'd learned how to program. Okay. Most of last year, when you were working with me in C Sharp, in JavaScript, we didn't really favor the object-oriented approach, although some people did, and some of you did and worked very well. And that was your approach because JavaScript would allow you to be able to work with OO in addition to all the other imperative and functional approaches as well. Now, we talked about that in class at the time. And you did some Java all through last year with the algorithms and data structures courses. Yes, so you worked with those. So I'm assuming that we can move through this pretty quickly because the concepts are there. Okay, and we just need to remind you a little bit of what they are. So so that's the plan for this morning. I'm going to use examples where possible, but there's a little bit of theory at the beginning, so that because I want you to really get those concepts. Because if you don't get the concepts, then it becomes quite difficult to understand when do we use public, when do we use private, when do we use protected, all of these various terms that you would know already in some context. I mean, what do we mean by encapsulation? What's polymorphism? You know, do you remember polymorphism? No, for example, it's one of the key aspects of cool things about the whole inheritance model around object-oriented programming. And you have to know these and be familiar with these and have a level of understanding that you bring to bear when you're starting to design programs. So the plan today is to get through some of that, to revisit some of them, and to let you see some more C sharp. Right, so these are so I think this class should give you everything as a kickoff point, but you know, please feel free to look up extra resources, but yourself, and I think, you know, there will be things to click in here, and you can have a look and see. So really, as a review then, and you know this of course, is that OOP is a programming paradigm where they program applications that are organized around interacting objects, and objects are derived from classes. Okay? So classes describe something in the universe, you know, and then objects are instantiations of that class. Okay? So you may have an abstract thing or a concrete thing, and here's an instance of that. So if I say to you, car, well, the car object would be different from a car class, for example, because a car class, you'd have some notion of what's involved in being a car. But your instantiation of that as a real world object, car, will be slightly different from my instantiation because we'll have different perspectives on what a car looks like, our expectations of that car. Okay? So we tend to have a model, which is the class, and then instantiations or realizations of that model as real things. So if I say I'm going to make a risotto, you know, and cook a risotto, then, you know, we have a general idea how to make a risotto, but then we have all these instantiations of that. Okay, so this is the real world instance now. Okay, so classes then are templates essentially from which we generate some objects. And the objects are instances of classes. And you need to be familiar with this. And, you know, guys, it's a really good idea to actually look at some of the notes sometimes and actually say the words, okay? Say these things. Say them out loud in front of the mirror or something, you know, or whatever, or to your friends, or, you know, to your imaginary friends. It doesn't matter. But say them. Get used to saying these things. Your third year students, you're going to be engaged in interviews soon for placements. And you have to get used to being able to see these things and hear yourself say the words. Language is powerful, really, really powerful. And, you know, sometimes we might be shy about saying it, or we might not say the word correctly and so forth. So get used to saying them, and get used to saying them in front of people and talking about them and using the correct language. Don't say the thing or whatever, you know. If it's a class, say class. If it's an object, say object. You know, get used to doing this. That confidence around the language and using the language will help you understand and learn the language, and it'll also ensure that you become more confident and competent when you go to an interviewer. So please get used to doing this. At the core, objects have attributes. And these describe the features of the objects. Okay? So, understand what an attribute is and what a method is. And a method, they are used to interact with the object or an instance of that object, and they provide an interface for interacting with that object. Okay? So all the words that are in orange up here are keywords that you need to know, and you have to really know what these are and remember these. Okay? So if you think a lamp object, which is quite simple, it'll be an instance of a generalized lamp. Notice the lowercase l sometimes and a capitalized L, because this is the kind of thing we do when we're generating and writing code. Okay. So a lamp class will have a state, like the lights here. Generally, they have that's an attribute that can have two states called on and off, and the interface could be a toggle, which could be a switch that allows you to be able to change the state with every interaction. A quite minimal interface. Okay. As you devise and develop more complex objects, then they will have more complex interfaces. And you can be devising, you as designers of classes now, not just consumers of classes, will be designing that interface. As this course is about, as we move from progress, you'll see about how to design things. Okay. So the other words that we need to know about are like object instantiations. That's a way we create these objects from these templates, and then they're able to use the interface methods to change their state. Sometimes they're called fields. Sometimes they're called attributes. So in other words, it's like sending an object a message. And we often talk about our design of applications are really centralized on message passing. And we talk about systems being collection of objects that communicate with each other via messaging, okay, like humans do, okay? And that's our perspective on the world. So and really, it's a perspective. There are other ways to do these kinds of things. You could have a functional approach, which would be very different to this. But for OOP, this is our way. Have you done some software engineering already? Separate to this, have you looked at interaction sequence diagrams? Yeah, did you do this? Yeah, I see nods. Yeah, so some of you will and some of you won't. But so that's a design which essentially gives us a walkthrough of a program and an application that actually shows how messages get passed from one object to another object to another object in order to fulfill some use case or user story or scenario. Okay, so that's how these things work. So these are the core language features that you have to become familiar with and know about. Okay, and that's nothing to do with coding. That's a perspective on a paradigm. Okay, and this paradigm is your way of doing things and looking at things. Okay. When we try to design a solution to a problem, we often adopt a paradigm and we work with that paradigm. So this is our way, our modular approach. So if we look at the OO way, then we look at the world as a series of communicating objects. If we look at the world, in a functional way, that's a different approach. And we design our programs in a different way. Okay, so when we encounter objects and classes, we need to know about some key terms, okay? So we need to know about class variables, instance variables, and member variables. And class variables are variables that we declare inside our classes, and they belong to the class. There's only ever one per class, and there's only one copy of the variable. We also have actually class methods, so that there's only ever one in existence as well. So we have instance variables, and instance variables are the actual individual object data, and every object has its own copy of that variable. Okay, so if you have two lamps, so we have a lamp class, then we have a state for each lamp, and then we want to be able to say that the state of this particular lamp is on or off. The instance variable holds that. Okay, and we have member variables, and member variables is just a collective term that we use to refer to both the class and the instance variables. So as I said, we use the same terms when we refer to methods. We can have class and instance methods. Okay. So object instantiation then, that involves calling a special method called a constructor. Okay, and constructors may contain parameters, and these parameters facilitate the initialization or the customization of the individual objects using these parameters. you could have more than one constructor. Have you done that before? Yeah. So that's called overloading the constructor. Yeah. You've seen this. You could have methods with the same name but different parameter sets, and they're called overloading methods. Okay. So you might want to be able to do that at some point as well. And you can have lots of different overloaded methods. And I mean, if you have a class hierarchy where you're inheriting from a class is inheriting from another parent class or parent classes, depending on the language that you're using, then you may override methods and you may overload overridden methods and so forth. Okay, so you've done all this stuff you probably haven't had to think about it since first year, but it's very much important, an important thing you need to remember now. Okay? So OOP is based on some really core principles, okay? And we'll go through this quickly because you know this, but encapsulation is really the core aspect. So that means that the implementation details, the state of the object, they're privately held inside some wrapper, which is the object itself, okay? And that's derived from the class. Other objects don't have access inside the class or the authority to make changes to the state of that. They're only able to call the object, create the object, call the object methods, and work with that. And we do that using a list of publicly available methods. And that is an approach to what's called data hiding. And that provides enhanced code security and also allows you to have unintended data corruption avoidance. Okay, we don't want to do this. So if we hide all the information internally, and we may have a model of something. We have a class, a representation of a model hidden inside some class, and we just define an interface, how we interact with that. We might not be happy with the way it's actually structured internally, but later on we might like to change it, so we can change the internal structure, the properties, and retain the same interface. So it allows us to be able to do multiple kind of development, and we define an interface around that. So the other key one is abstraction. Abstraction is where objects only reveal the internal mechanisms that are relevant for use of other objects. Okay, hides all the unnecessary implementation of the source code. Okay, it means that developers and consumers can more easily make changes and additions over time. So it's simplified and efficient. Okay, so this is all about constantly abstracting and reusing and reusing. Okay? Now we're going to see these again later. And the point of knowing these and knowing the point of these and understanding these, is, more importantly, is that you can see why we have design patterns a little bit later. Okay, and that's what's important. Inheritance is great. Okay, inheritance really, I mentioned it already, but that's the relationships and class hierarchy. So there are subclasses. They allow developers to reuse shared code and maintaining this unique hierarchy. Okay, and that's a key principle of OOP. But you do require thorough data modeling, and then in order to be able to build a class hierarchy, you don't just do it any old way. Okay, they say, or the theory is that it reduces time and errors, but it depends on the design. And the downside, of course, is that you tend to be programming in the small as students. You don't often see the necessity for this structure. It seems like I've got to write this 150 lines of code that I probably in OOP that I could have just done in 2 lines of Python. Okay, but and you don't see the fact that this really only applies and is necessary when you're writing the millions of lines of code. And we can't give you an assignment that requires you to write 1 million lines of code. I know I give you lots of hard assignments, but if I did 1 million lines of code, I'd be ambushed, So it's not good. But sometimes you have to realize that you don't see it until it gets bigger. Okay. All right. And this is why we use these languages. My favorite feature of polymorphism is that objects can take on more than one form, depending on their usage context. Polymorphism, many forms, okay? So the program then will determine which meaning or usage is necessary for each specific execution of that object and reduces code duplication. Have the same method sets, but they're different, okay? So this model, okay, has attracted criticism. You know, I mentioned you know, doing it in the 2 lines of Python. A few of you tittered, you know, and get it, and rightly so, you know, but because that's your experience to date, of course, right? So you have to really, you have to say, well, why you at this stage, you know, third year student, you know, in first year we tell you this is the way, you know, this is the way, do it this way, and you accept and you get on with it, like, you know. But you know, when you get to third year, you have to be a bit more reflective, because you might get a job and be asked, well, what language would you choose to do this and why? And what are the problems with this approach? Down the line, if we build this API or this service that we're going to put online and we want to make it available, well, what are the problems with this? Where are we going to run into problems? Will it scale? All this kind of stuff. Yeah. So you're going to have to look at that. And it has been criticized for many, many reasons. And you should look at these issues and have some sense of these issues. This course is not just about coding. This is about thinking about your coding. It's about design. Okay. And you know, you need to be able to look at it and understand it. So an alternative approach I mentioned already was functional programming. And that focuses on the evaluation of expressions rather than the execution of commands. We have structured programming, okay? The 3 ways: sequencing, selection, and iteration. That means they're sufficient to express any computable function, and imperative programming. That focuses how a program operates. So there are these approaches, and you should know the difference between all of these, okay? The developer's largest concern with OOP is that it overemphasizes the data component of software and doesn't focus on the computation or the algorithms. Okay, so OOP does not effectively handle concurrency. Do you know what I mean by concurrency? Doing 2 things at the same time or multiple things at the same time, yeah? Okay. It can be more complicated to write and take longer to compile. So there's a brilliant, brilliant article. I love this article. I always recommend this article. Why are so many developers hating on object-oriented programming? By David Castle, okay, 2019. It's something to really read, okay, and have a look at and have an opinion on it yourself, okay? When you read these things, say to yourself, what did I learn from this article? Do I agree with this author? Do I disagree with this author? You know, and you can apply the same thing. What did I learn from Keating? Do I agree with him? Do I disagree with him? You know, whatever. But what matters is that at the end of the day, you have to have some opinion for you, so that when you're asked the question, and you will be asked questions in interviews, have some opinion and understand your opinion, okay? So please do this. If you do nothing else, you know, do a bit of self-reflection here on this. It's really, really important for your professional development, okay? Great article. Read it. It's good, you know, 10 minutes on the bus or whatever, you know, it's super. Again, another article I'd like you to look at is, again, from Free Code Camp, How to Explain Object-Oriented Programming Concepts to a 6-Year-Old by Alexander Petkov. Okay? Try doing this. Try explain this concept to a child. Okay? You might understand the difficulty we have trying to explain things, you know, as lecturers. Okay? But sometimes you might think, oh yeah, sure, that's obvious. Well, actually, you know, I've been teaching for 30 years. You know, I forget sometimes that people might not have the same experience as me. Take longer to get it or something. So I always try to say, well, how do I explain this? And this is not patronizing. This is, you know, you have to really understand the question, because kids ask really hard questions. Okay? If you don't get it, they'll crucify you. Okay? So you have to really understand this. Okay? It's accurate, it's insightful, it's not patronizing, and it helps you review your concept. It's like and it deals with cats. Okay, so we work from this. Okay, so the focus actually has been able to explain accurately OOP in an interview context. You know, because you might need to go beyond. You have to go beyond copying and pasting stuff. Okay, you actually have to really take time to understand this. So please do this. Okay, it's really, really important for you. Okay. Okay. Right. So that's the theory stuff kind of done. Let's have a look at C#. Okay. So a lot of the time we build programs and design classes, and students tend to have issues with access modifiers. Okay, so when you create classes, you create objects, you create members of those objects or those classes, then you have to add modifiers in order to be able to do these encapsulation. Okay, hide stuff, right, and limit how it's accessed. And the whole idea of that is that it's not to make life difficult for you, but it's to help the people who are consuming or using your classes to be able to use them correctly. Okay, minimize the errors. Okay, so we need to. So you've seen some of these before. We have public, protected, private. You've seen these from Java, yes. So there's one called internal as well. And there's combination one modifiers called protected internal and private protected. Okay. Public members can be accessed from anywhere. Protected members can be accessed only within the class itself and accessed by inherited and parent classes. Private members are limited to the containing type. Okay, so that could be an interface or something. And the internal members can be accessed from within the same assembly. That's an .exe file or a DLL. Okay, dynamically loaded library. And you see these when you're programming in Windows type environments. Okay. The protected internal class can be accessed by any code in the assembly or from a derived class within that assembly. And you know, these are heavy duty concepts in terms of you need to be doing examples to be able to see them. But I'd like you to check and have a look. What's important, I guess, is that there's this table, and you should have a look at this table and understand the table. I've given a link to the table here, so I think you should be able to get there somewhere. Anyway, there's a link, okay, and you can have a look at these, and it'll explain it, okay. And this really is to tell you about how C# does encapsulation. Okay, so what's important is let's see some programs, okay? That we always want to see demo programs, okay? I have a little red. I need to see what this says here now. Okay, I see what this is. Okay, so there's a note here for me. When I see red flags like this is to remind me to do something, okay? So this has got to do with my demo code, okay? So sometimes students mail me or send me messages in Teams, which I always welcome, and it says, I can't get your programs to run. I downloaded that file from Moodle and it's not working for me, okay? The code looks okay, but it's not running, yeah? I get this error. So usually what happens is because when I developed something, I'm a Mac user, okay? So I have everything running on a Mac. So I have a specific runtime environment installed. So I tend to use the lowest level one, which is 3.1 for the .NET runtime, because I know that will work across many different kind of operating systems and what people use, okay? But then when you install your .NET, you might be installing 5.0, which is the later version. Is that correct, yeah? Seen this? And that means that, you know, you're copying all my stuff and it's just not working, okay? So you need to make some modifications, right? So you need to set up your project file in order to make that work. And let me see if I've got something. Okay, so what I have here, so I run Parallels on my Mac, so I'm running Windows on my Mac in Parallels as virtualizing. Okay, so I'm running Windows here. So this is the Windows version of VS Code running in the Mac, and you'll see that so this is one of the programs that I downloaded myself from my own Moodle page. And what's important, I guess, to see here is, okay, so I have a framework here. Target framework is .NET 5.0. So let's have a look and see. That's because I've made some changes, I guess. So it's not behaving. So let me see if I can. Okay. Not happy. Doesn't like my Windows is not happy at the moment. Okay. Okay. Let me get rid of this. Let me get rid of this. So really, what you need to be able to do is to be able to look at your project file, okay, under your app. So this is the My Access one, My Access, and you need to probably change from 3.1 here to 5.0, okay, and that will work for you then at that point. Let me see if this is not working. My Mac is not behaving very well now for some reason. Okay. But anyway, that's what the problem is. Okay, so you can fix this. I've also got Mono running on this as a Linux Mint running as a virtual server, virtualizing, and so all the programs work on those. So I'm testing, I make sure they work before I send them to you. The way you need to make some changes is to modify this. Okay, so that was what that red flag is. So let's go back and have a look at this version. This is the code, and I'm going to talk about it first here. Okay, let's have a very simple class. Okay, so this simple class here is a person class, and it shows the different kinds of data members. It shows the access modifiers for public and private in use, and it's called myaccess.cs. You can find it in the demos file. Actually, it's called program.cs, and it's in a directory called MyAccess. And note the use of the property for the same. Up here, where's this? Here. Okay. We can see properties here. I'm doing some fun things here, and we can see the difference between those a little bit later as well. Okay, so really what's happened is I've created a class called person. Okay, and I'm now creating a private int age. So this is a private member here, so it's only accessible from inside the class. I'm creating a string which is public, so that's available. Okay, that's not public, by the way, that's private. Okay, this is an alternative way to actually create getter and setter methods. So you remember your getter and setter methods from your Java programming, where you have a variable, you hide the variable by making it private, then you provide a public getter and setter methods that allow you to be able to do those changes. Okay, so this is a very, very common practice in object-oriented programming, and C# provides you with a really neat and quick way of doing all that stuff. Okay, and you can use that using something like a private string name, and then you can set up a public string called name and set up your getter and setter functions associated with that. And it's a nice, quick way of replacing all of the code that follows here. Okay, so it's straightforward, easy. There's an even shorter way of doing it. Okay, and I like short ways because I'm lazy. Okay, virtuously lazy. Okay, as Larry Wall would say in Programming Perl book, and if you've never read that book, have a look. It's really good. Okay, there's nothing wrong with being lazy. Okay, and when it comes to coding, so you can check this. You can check this code. You can run it here. And it should do all the work. Okay, so when you see this piece of code that I give you, okay, what do you do with it? Do you just do what I just did there now? .NET run, ground, that's tick, I've done this, okay? That's not why I give these demo programs. I give these demo programs with commented sections here because I expect you to uncomment that and then comment the parts that and replace the other parts, okay? So that you are looking at the different ways to do this. I want you to learn from the programs, and you only learn by making changes or working or playing with it. Okay, play is really important. I mentioned this before. We learn from play. Okay, so play with the code, change the code. You know, if I uncomment this, what's going to happen? What's going to happen when I uncomment that and run it? Any ideas? Huh? Yeah. Yeah, okay, so I'm redeclaring something, I'm going to get some more errors. Okay, good. You know, think about what's going on. You know, I expect to get errors. So when you make changes, you run. I should have saved it maybe. How about that? Okay, we get errors, okay? What we expect. So when we see all these red errors, we don't panic, okay? We know we're going to get errors. We expected to get the errors. The trick now is to look at it and say, is it the error that we expected to get? Okay, let me have a look. Yeah, it says the type person already contains a definition for name because we have name up here, and here we are starting again, okay? So yeah, so in order to make it work, we probably need to comment this piece. Yeah? Okay, oh, more errors, okay? So there's more going on, okay? I'm not going to tell you the answers to that one, okay? Because it's got to do with the methods and you should try this yourself, okay? Okay, so there's the whole point, I guess, is to be able to take a few lines of code and make it work and understand how it works. In a coding interview, you will be given a piece of code and say, what does this do? You need to be able to read and understand and have a sense of what's happening here. Okay? Learn to do this by playing with the code. And if you don't want to do it with my code, take your own programs and make changes. Look at the different ways to do it. So we have essentially two designs of a program here to implement encapsulation. So maybe you should try and see the different approaches and learn something. Because you may be doing something one way, and then somebody else is doing it a different way. And then, you know, you may be only doing something one way. You go to a coding interview and they're doing it a different way, but they're essentially doing the same thing, but you're not familiar with that approach. So looking at code, don't want you to just look at it. I want you to engage with the code. So please do this. Okay. Now, yes, okay. So I had a request from a student yesterday about tables, okay? And it was a really good question, you know. Is the student here? Do you mind me saying? No? 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 Yeah? Do you mind me saying? Okay, okay. So Tamara mentioned and posted me this question, very late I might add, okay? I generally don't respond late at night because I'm having a life, you know. But that's the plan anyway. But as it happened, this question got me thinking. So I was up at 6 this morning and I did a bit of work so I produced this demo, not just for tomorrow, but for everybody, okay? A really, really good question. And the question was, and I like getting questions, like sometimes I might get questions and I just think, oh, that's easy. You should really be doing a tutorial or something. Sometimes I get ones that are hard. So if you come across something that's bugging you, you know, do mail me. And if I find I can help, I will do that, okay? I'll write something and I'll show it to you in class, okay? Or personally, in this case. But this one was an interesting one because the question really centered on, and it's, I don't do this to say, oh, this person doesn't know how to do something. You appreciate that. That's why I asked in advance. It's because, yeah, it's tricky, actually. And, you know, you're not familiar enough with the language at this stage to know the nuances associated with this, especially in relation to manipulating arrays. Because, you know, and it's a really interesting one. So the question really centered on, I want to be able to work with a table in a class in an object-oriented way. But the thing is that when we declare arrays, they come with fixed size. And how do we create classes and tables around arrays when we don't know what they are in advance? So we might want to specify, I want to create a table of a particular size, but later. So you want to work with a table, but you want to have a late instantiation of that rather than early. Does that encapsulate what you're saying? Okay. So thanks for this. So it caused me a couple of errors. I kind of knew what I needed to do, but it actually caused me a couple of nightmares, you know, trying to figure out how to make it work. But anyway, so I'm going to show you the example. It's a very simple example. In the end, a lot of these things are simple, but and it relies mostly on understanding or lack of understanding. And I, like everybody else, have lack of understanding on many an occasion. So really what I decided to do, now this may or may not, we can talk about this. I'll give this to Benham and you can talk about it again in the tutorial. Okay. So my approach to this was I wanted to be able to create a table class. And in that table class, I wanted to have a table object, okay, which we'll be able to use to represent the table. Now, how I actually represent that table internally is just how I do using an array, because you specifically talk about arrays. I could have actually represented a table using a hash table. I could have represented it using a linked list or lists of lists or something. I could have done lots of ways, but all that matters is that I need to be able to create a table and be able to make sure it's the size that I want it to be able to do and be able to have some methods, for example, that show me the table, okay? So, so I created this table here that has a number of rows and a number of columns, and then I created a table. You'll notice that this form that I'm using is that alternative form to creating getters and setters associated with members of a class. Yeah. So this is the short form, the lazy form, okay, that allows us to be able to engage with those and interact with those via an interface. So we're essentially setting up an interface, we're doing all that work. So there's a property which told me the number of rows, the number of columns, and ultimately, let me scroll down to here to my program that uses this. I really wanted to be able to create a new table of this size randomly at any point. So whenever I wanted to create a table, I could create a table. But the problem with doing that with an array is arrays are fixed and they're immutable and all this kind of stuff. Okay, so I hide all that stuff, okay, from you. So I'm kind of twisting it around a little bit to something I wanted to show as well, in addition to the questions you were asking. So this allows me to be able to create a table of any size at any point dynamically. I don't have to predefine them. Were you having this problem of predefinition? Yeah, okay, so this gets around that, okay, in a way. So you don't know or care or need to know or need to care about how I'm actually representing the table. All you need to know is that I have this table object and it has this particular size at this point. And whenever I want to create a second table, I can create a second table. Yeah. And once I know I have a table and I can add data to that table, then I can use all the methods to say write table as LaTeX, write table as Markdown, write table as HTML. Yeah. So I can generate this. And then the functions may change over time, or it doesn't matter, as long as I get the data into the table, as long as I can create a structure of the table, get the data into the table, then all those methods will work with the table. Yeah. So that's how this works. And this is encapsulation in action. So let me see if it works. Let me run it and see does it work. Because I had a fun time doing this. But so I created this table. It's an object. And I can tell you that inside that object, I'm actually using an array that was allowed to be able to create later. Okay. So then I actually randomly generated strings and added it to every element in that table, so I could set up and initialize the table just to prove to myself that I could change all the elements in that table, and then I could print and call various bits and pieces. Okay, so I created a table object. I had a show table which allows me to be able to show me what the contents of that is. So I could say show that table as HTML. All that matters is I need to be able to iterate over this array, and I don't have to specify sizes or anything anymore. Once I create the table, all that stuff is held internally, and I can reuse it, and I just say show table. Like so, I can say my table dot show table. Okay, and I could write a method called my table dot show table as HTML or show table as Markdown, and then use the same formats to be able to produce that code. Okay, so not too tricky really, but I just created this table. But I happen to be using an array internally because Vanessa's question was all about, Tamara's question was all about that particular using arrays and late generation of arrays, okay, or late instantiation of that array, because arrays are essentially objects, okay, as well. And once we remember that, that's fine. But I could now today actually keep this program as it stands, my engagement with this class, and I could change how I represent the table to use lists inside if I wanted, or hash tables, or anything else I feel like. Okay, so let's have a look at how we do this. So I guess what's key here is this thing here where I'm creating this array, this table array, which is a two-dimensional array, and it's called a two-dimensional jagged array. So the fact that it's jagged means that at the time of creation, I do not have to specify the actual size of the array. Okay, like that's really, really important. But so what's happening here is that my table, this private string, my table, that's actually creating a reference to an array which will be created later. Okay? And then I use the creation, so I actually will create the array as part of the constructor call, and then I will assign the array that's created, I'll point this to it. Yep. No, I could make it public, but the point is I want to hide it. The whole point of is the encapsulation is that I want to hide the internal structure. I only want people to be able to, or users or consumers or programs, to engage with the internal variables via methods. Okay. Now the only method I'm providing is just to show me the contents of the table, but I could have extra ones. But I'm not going to give you everything. Okay. Okay, so later on then, so I also wanted to do some static, I wanted to do some random string generation, and this was a useful exercise as well to show you that here's how you generate random length strings, okay? And if you've got issues, go to Stack Overflow, but if you in your assignments, and you find something like a function, something like generate strings. We use this all the time. We did it, for example, when we looked at JavaScript and so forth. I'm using a modified version of this, but I'm crediting where I found it, okay? Right? I'm not just going to pretend it's my code, all right? So you do this as well, please, all right? Nothing wrong with using stuff and showing that you know where to find stuff, because often in an interview, might be asked the question, so, where do you go when you don't know how to do something? Yeah? They want to be able to show, well, are you going to be bugging me? That's what the interviewer is usually wondering, can you help solve your own problems? So if you can, then go there. Okay, so show, this is fine. So this is an example. Let's get to the good bits. So here's my table that shows the table, and it iterates over the number of rows, and essentially we can access the table here. And this then is independent of the size of the table, because it's using the internal properties to be able to do this. So you know how to do this, just two for loops, one inside the other. It's easy enough to do, but this is how we access it. It's first year stuff. And I guess the interesting piece then is that when we look at the constructor, we specified the number of rows and the number of columns, and then these came through the constructor. These are the parameters for the constructor, and then we assign the value of num rows and num cols to these parameters. So this is the data member. So that's held internally in the class, and this is how we create the table. This line here. So this actually is the core of a question you were asking me about creating. When you don't know the size in advance, you can do it like this. So you can create an instance to the table, and then you can tell that table we fix number of rows, so that sets up the rows, and you're saying each row then has a jagged array reference to its columns, and then we have to actually iterate over each of those rows and manually create each of those columns in a jagged array structure. Okay, and that allows us to be able to dynamically create arrays of any size when we need them, as long as we know they're two-dimensional. I couldn't create a three-dimensional one. I have to at least know the dimensionality of this. Okay, so I can iterate over that table, and I'm using length of this row rather than num cols, because I can, and that's just to do that. So I'm actually creating a new array. So an array of arrays. So each array, and it's a bit like the Java way in a way, yeah? It's a bit Java-like, okay? So really, I suppose, and then I'm initializing this. So once I've initialized it, I can just use the number of rows and columns that are held internally, and I'm generating a random string, and that's why I'm getting all of these 5s here. But I could create my program, and I could just do something like this, 4, 3. Okay, and I can change all of these. I could ask from the keyboard to enter the size of the array you want, and then we could create the array dynamically as well if we wanted. Okay, does that help? Okay, it helps me, okay, because it helps me talk a little bit about a fresh example in terms of encapsulation of data and hiding and manipulation and methods and so forth. Okay, that might also be useful for you in some way for your assignment. All right. Any questions or further questions? We can talk again after this if there's other aspects of this. But you get a sense of how we manipulate and use data structures, have some encapsulation, some hiding, all that kind of stuff. I can create another table in my program if I wished. I could just take this one here and say, I can do this. So I can just create as many as I like, whatever size, whatever, I'm working from there, okay? It doesn't answer the question as to how do I figure out in advance how much a size table I need, but that's a different question, okay? You might have to do some analysis in order to be able to figure that out, and some parsing, but I'd say that's a different question. Okay, so that's a little bit about playing with OOP. Another thing we need to actually be sure about, and all of these examples are available. You can look and run them yourselves afterwards. Okay, so we want to look at inheritance, and here's how we deal with inheritance. So normally we have a base class, and we inherit we inherit something from that base class when we extend it. So we can inherit the instance members, the methods, the properties, and every class. When you define the class, okay, you decide and allow what you will allow to be inherited. You have control over this. You know, somebody said you can say public, and it was a good question, but why would you want to make it public? You know, the last thing you want to think about is public. So, you know, you have basically I hide everything and then start making the bits public that I need to make public. Okay, and that's really a good approach to doing this. Okay, so this is how those access modifiers, protected and private use. This is called myDerived.cs, or the program is myDerived, and you'll see that there's specifically allowing us to be able to we use this colon syntax, sorry, to show where we're extending or where we're defining. So we have, sorry, I should have done. So my base class is here, and it has a public string, a protected string. I'll see the question, give me 1 second now. And the private variables here, and so we create this derived subclass then called derived, and we use this colon to do this, okay? And we can get the bits that we want. If that's private, I might not be able to do it, so you can uncomment this and have a look and see what happens when you run the program, okay? Again, please, when I have the commented text, commented code, try uncomment and see what happens, okay? Generally, I comment something that will give errors unless you make some changes or something, so please have a look at that. Sorry, you had a question there. Sorry, just 1 sec, this is the noise. Thanks. It depends where you use them, what you decide to do with them. Okay, so because if you look at the example that we had, it's a good question. When we go back to this one here, here's an object, okay? So I haven't said what it is here because I'm using this, but the class is public. So that means I can use the class in order to be able to do something. But I might have an inherited class, I might use this class, and then I might want to hide how I structure that table from somebody else, and I might want to make that particular instance private in this particular app, or public if I want to actually extend my class. Okay? So you can do. But for this particular example that I was looking at, I'm talking about the classes being derived and the members, you know, in terms of that. But you could have objects internally as data members and make them private and public as well. Of course you can. Yeah, absolutely. I did something funny with the random number generator in the previous example. I'll just see if I can go back to that, because that might help a little bit as well. So if you look at this one here, you'll notice, you will now because I've told you, that I actually created a private static random. So I created this new random object internally in this class, but it was private, so it wasn't going to get out of this class. I made it static, which made sure that I only ever created one of them, so that the random number generator wouldn't be a random number generator generated for every single object, but it would just be in the class. So I could call it from within the class, and so that would be fine. And later on, when I looked at random here, this variable here that I created, it meant that I was going to be accessing the one that was in the class. But it's not available anywhere else. Okay? Couldn't access it outside the class. Good question, okay? But any other questions or further questions? Okay, so we can see then that we can create, and I guess when you were looking at your Java, class A extends B, yeah? Class A extends B, comma C implements D. You know, an interface is implemented from something, yeah? Something wrong with that sentence, wasn't there? Yeah? No? Okay. Class A extends A, comma B. Class A extends B, comma C. Can you extend from multiple classes in Java? No. Okay. So I'm testing you. Okay. Right. That's why we have the extends. We use interfaces to get over the fact that we can't have multiple inheritance in Java. Yeah? You have to remember some of the stuff from Java, please. You know, okay. So in this one here, we don't have the multiple inheritance either. We have to have single inheritance, so we use interfaces too. Okay. So it's a good one to have a look at. Polymorphism. is that key one. We've 5 minutes or so left, so we'll try to get through polymorphism. Very simple class. Let's say we have an animal class. Okay, it's a base class, and it provides a public virtual void animal sound, so the animal makes a sound. Okay, so that's the default sound. So when we say animal sound, this is what happens. If we have a cat class, and then we say the class extends or is derived from animal, then we override the sound and say the cat says meow. With the dog, the animal sound says the dog says woof. Okay, so we're overriding the default method that's provided in this. Okay, you can look at W3 Schools if you can't remember this, and they do one for Java as well as C#. Okay, so the many forms here. So when if we create an animal, and then we create a cat and we create a dog, we end up knowing, well, which sound do we make? Because we can sometimes cast. Remember, we also talked about boxing and unboxing to a different object, and then we can see which method do we actually call. Because it depends. So you look at the object in context, decide, well, what object am I now? This is the method that I use. So there's two classes. You might downgrade an object, which is a more refined or specialized version of a class. So to a parent class, and then you end up calling the parent method. Okay, that makes sense? Yeah. So there's lots to think about in all of this. Again, there's a full program with this example here, so you can look at it and make some changes. Let's have a quick peek. So I think it's my derived. Let's have a look at this program here. Here's my base class. Here's my, oh, that was the derived. Where's the other one? What did I call it? Sorry, my poly, very good, yeah. I should have really had them as birds and parrots. But anyway, here's animal. Here's a cat, which is derived from animal. Here's a dog, which is derived from animal. Here's a program. So here's an animal, which is my animal. So that's an animal object. My cat is a new cat. My dog is a new dog. And run this, so I should get what I expect. So let's go into poly, cd. Okay, so the animal makes a sound, the cat says meow, the animal makes a sound. Okay, oh, because I said my dog did animal sound. So why is that? Why is it not saying the dog says woof? Okay. Any ideas? Yes. Sorry? I didn't, yeah, okay, because I didn't override the method. But where exactly is this problem coming from? Did you expect when I said dog inherits animal, overrides the method, the dog says woof? Okay. Animal sound, you expect that to say the animal makes a sound. My cat, the animal dot animal sound, the cat says meow. My dog dot animal sound, the dog says woof, but it doesn't. It says the animal makes a sound. Why? Yep, it's got to do with the whole casting thing going on here. Okay. Yep. So if you don't understand this, okay, you don't understand polymorphism. Okay, that's why I give you this piece of code. Okay. Yeah, I want you to work with it. What happens if I did something like this? The dog says woof, right? So I made a slight change there. Okay. So a lot is happening here with just me changing the word dog. My dog is a new dog from Anno. Okay. So this is the kind of thing that you could ask in an interview. Okay. Do you understand polymorphism? Well, show me this. What will be output of this piece of code? Okay. If you really understand polymorphism, you'll be able to give me the correct answer. Okay. And know why. It's an exercise for you to go and figure this out. Just give me 1 sec now. We should be able to get back to this. Please. And again, we were looking at abstraction. We can have abstract classes, which forces you to create instances of the methods, and it's no different to your Java version of abstract classes. And again, there's a program that will allow you to be able to my abstract, and it will show you about this. Okay. I'm here if you have any questions afterwards. Thanks for your attention. There's a lot to cover today. Have a look at the lessons. I'll release them a bit earlier as well. I'll release them later today, okay, rather than tomorrow morning. Okay. Thank you for coming.